welcome to the Backend Microservices workshop. And first, I just want to give you a little bit of information about myself because I know I'm the one sending you all those emails, but not a lot of you know who I am. So basically, I'm a student at Cal, obviously, and I have been involved in multiple backend development throughout my internships, and I'm still a student. So keep in mind, I'm still learning a lot of these things myself, but I feel like I've learned enough of the basics to kind of like teach you a little bit and kind of give back as I do. I recently started contributing to the Fast API open source repository. So if you're curious to know my GitHub, you can definitely look at my Fast API GitHub repository and see my commits there. So yeah. Now, a couple of downloads I have for you guys to start off. Hold on, I'm going to turn off the chime. Okay, so I want you guys to download some kind of like code editor or something like that. I use Visual Studio Code, but you don't have to. You can use something else. And I also want you to download this database browser. Now, you guys probably don't have this link, so I'll share it in the chat. I'll explain what this is in just a second. But yeah, so go ahead and download those two links. And I'll give you guys a minute just to kind of like download those, get set up and like get situated. At any point in time, if you have any questions or anything like that, feel free to unmute. I think we're like a small enough group that you can just unmute and just speak what's on your mind and stuff. So yeah, I'll give you guys a few minutes to download this. Okay, so is everyone done now? Does anyone need a little bit more time to download these things? Okay. All right. So Apple cannot check it for malicious software. That's why I don't use a Mac. I'm actually not sure why it says that. I'll have to research more about that. With Brew, you probably can, but I'm not sure. They have like a Mac. It can download, but it doesn't open. Yeah, you can also download Sqlite as an extension, that's true. But in this demo, I'm going to use DB browser. I'm researching it right now. I don't know if you can. Yeah, I'm actually not sure. Okay, so Elaine seems to have a solution. Open it from system serve preferences. Yeah. Another solution to that is to get a Windows computer. Okay, all right. So I'm gonna move on. If you guys don't have it downloaded yet, that's okay. I'm not gonna be using it just yet anyways. So just keep it in the background. Okay. So basically you're here because you know Python. If you don't know Python, then you can still follow along. You can still have the conceptual understanding, but you probably won't understand kind of like the deep live coding segment of it. And again, that's totally okay. The most important part of this is to make sure you understand like what scalability is and how you can actually build the backend. Because I'll be honest, like the actual coding part is pretty easy. So you can learn that at any time. Okay, so Preeti's asking for the download links. I'll do that. So that's Visual Studio. Oh, I'll put it everyone. That's Visual Studio. And that's Sqlite. Cool. All right. So yeah, so you're here because you want to know how to build a scalable backend. And that's what we're going to talk about today. But first, what is kind of the backend, right? You hear a lot about, there's this thing called the backend. You probably have heard of it in like many tech terms before, or like stuff where you're figuring out like what job you want to do. So a backend is a type of role within a company and also a type of data layer. But it refers to any part of the website or software program that the users do not see. So this could refer to the API, or it could refer to the database. It could refer to kind of a separate like for example, an email microservice that you have going on to send emails, like an Amazon Redis server or anything like that. So anything that the user does not see is called the backend. And anything that the user sees, like the actual physical web application or like a mobile application, is the front end. And that's kind of what I call the presentation layer. So the backend is the data access layer, while the front end is the presentation layer. So that's kind of the terminology there. You've also probably heard of the term web API. Web API generally refers to both sides of computer systems communicating over a network. So basically how a front end talks to the database and to the server, that's called an API. It stands for Application Programming Interface. So that's a web API. And the server-side portion of the web API is a programmatic interface to a defined response request messaging system. So that's important when I say response request, because the front end sends a request and then the server sends back a response. You're going to see a lot of these terms reflected in my live coding segment here, where I show you, that Fast API refers to these terms as request and response. So yeah. There are several design models for like how to build a web API, how to build web services, but the two most dominant are SOAP and REST. We'll be focusing on REST today because that's what Fast API uses. That's what like a lot of people use. And a REST API is easier to use for the most part and is actually more flexible than SOAP. It has a lot of advantages, including that it's really easy to understand, right? Because the only four kind of like things that you have are get, post, put, and delete. Now there are more, but these are kind of like the request types that the front end makes to the backend API. And I'll go over this in a second here, like what actually get, post, put, delete mean. But for now, just know that REST API kind of like entail these kind of four things. So I want to give you kind of an example where this is like a get, put, post, delete kind of endpoint that you see here, right? So this represents a client calling the backend API with these following request mechanisms. So the first one here is like the get request. And a get request is basically a request where you're finding a pet or by ID. So that's what this is saying here. and it basically wants to find, something, and it wants to get the data of it, right? So that's what a GET request is. And a PUT request updates the pet that you have here. This delete request deletes the pet, and this post request, uploads a new pet. Over here, I think it says image, but it's basically the same thing. So this is what correlates to create, read, update, delete in CRUD. So yeah, that's kind of what REST API is kind of all about, and pretty much what this whole entire presentation is going to rest on. So I want to pause here because I know I spoke kind of fast there, but does anyone have any questions so far? Is SQL a REST API? So SQL is not an API. SQL is a database. So it's basically a database language, and a database is where you store all your data. What is the difference between put and post? So that's a great question. Put actually updates an existing piece of data, so something that's already in the database, but post uploads a new set of data. So basically, imagine you're on Facebook, right? And you change a setting of your user account. That's a put request, right? Because you're changing something that was already there. But if you make a new Facebook account, right? You're making a new Facebook account. That's a post request because you're making a new kind of thing in the database that Facebook has now. Got it. All right. What would you use these commands in Python? So you would use these commands in Python. Python is just a way to program this interface, right? Right now, Python isn't even in the picture yet because we haven't really talked about any languages yet. I mean, aside from SQL. But basically, this is kind of the whole concept of a web API. Basically, how servers are coded. This is kind of the concept behind that. What does REST stand for? I don't know what REST stands for, but I know it stands for something. I don't think that matters, though. Let's see. Representational state transfer. There you go. Yeah. It's confusing, but it doesn't matter. The only thing you need to know about a REST API though is this get, put, post, delete structure, otherwise known as CRUD. So that's what that is. Okay, now if you guys didn't understand any of what I said there, let me know, so I'll go through it again slower. I'll give everyone a minute to kind of gather their thoughts. Also, feel free to unmute yourself and talk if you want. Totally okay with that. So
CRUD is create, read, update, delete, right?
Correct.
So is put the update?
Yeah, exactly. Put is the update.
Okay.
Yeah.
Can post also be used to update?
It can, but at the end of the day, it all rests on convention. So this is where it gets confusing, right? Is that any of these routes can actually be used for basically anything, but it's based on convention and documentation that developers rest on this kind of convention that we have here, get, put, post, delete. So you can imagine this as kind of a function, right? It's basically a function where this kind of request, it leads to a block of code being executed in the server. So whenever the client calls this request, it executes some block of code. Now that block of code can do anything. The front end doesn't really know. It can basically do anything. But the get, put, post, delete kind of method headers tell it kind of a little bit about what it's going to do. If that kind of makes a little bit more sense.
Yeah, that makes sense. Thank you.
Yeah. Would you happen to know the difference between, Brian, I'll get to your question a bit, but do you happen to know the difference between REST and SOAP? Yeah, so SOAP I've never really used, but I know that SOAP uses XML for all their messages, but REST uses mostly smaller messaging formats like JSON. If you guys don't know what XML is, it's basically a data format, and JSON is also a similar data format. but JSON is easily representable in Python dictionaries, and it's also smaller and like more efficient to manage between like a server load. So yeah, and also REST has a way smaller learning curve. I think SOAP is used in GraphQL, right? It's used in GraphQL, but GraphQL is like hella hard to learn. There's like a lot of kind of conventions that you need to learn. But REST API is so simple. You just need to know these like 4 method headers: get, put, post, delete, and then you're done with the REST API. Because if you think about it, all web transactions that you ever do across the entire web is basically kind of coming down to these 4 endpoints, right? For example, think about when you're you're opening a new Google Slides, right? You have a Google Slides that you made and you're opening it on your web page. That's just a GET request, right? You're just getting all the slides from the database that Google has stored for you, and that's a GET request. So similar to that, anything you want to do can be represented in these 4 method requests. That's why REST is easy. Why are get and delete both pet/pet ID? Good question. So whenever you get something or you delete something, you want to know which pet ID to get or delete, right? So this basically what the front end is going to do is it's going to say /pet, if you can see what I'm writing here, /pet/2. And 2 is the ID of this pet. You can imagine this is like a variable, right? 2 to pet ID. So whenever you pass it under a GET request, the server knows to find the pet, right? But when you pass it under the delete request, the server knows to delete that pet. It just turns out that the URL ends up being the same because you need that information anyway. So that's basically the same. But you know, the context of it is amazingly different. So you have to be careful there. Why wouldn't you put pet ID for your put request? Good question. Why is ID not used in put? So this is also kind of like confusing because you could put it in the put request. You could put pet ID here, but you don't need to because it's normally passed in as metadata. If you guys know what metadata is basically extra data that is attached upon this request. So it's kind of sent along with it because you can imagine like, you know, you can't just find out everything you need to know with just this. There's also some metadata that's attached to it. That's called the request body. Request body. We'll learn more about what the request body is a bit later on. But the request body basically contains the pet ID. So if you wanted, you could change the routes so that this get request would be /pet, and then your pet ID would be in the metadata, but it's just easier this way. So that's why you do it this way. So keep in mind that your web API is very modular. You could change it however way you want. So like the actual like kind of technicalities of these routes aren't really important. What's important is kind of like the get, put, delete, post, what those actually each do and what those represent. Okay, so it's the conceptual stuff, and then each of these is implemented through Python to API. Exactly right. So this is, the CRUD thing is the conceptual stuff, and then the conceptual stuff is applied to Python to build an actual API so that we can actually communicate with the server. All right, let's make sure I'm not missing anything. What is pet? Oh, so so pet is like it's kind of the context of which this framing is being used for. A pet is like, you know, like by that I mean like a dog or a cat, right? So like basically you want to make your routes descriptive, right? If you just kind of make them non-descriptive, no one's going to know what your routes mean. So for example, going back to the Google Slides example, if I put /slides, that would kind of tell me that, you know, this route has something to do with slides, right? So that's why. It's basically context. It all rests on context. Sorry, I didn't clear the context earlier. I should have done that. That's my fault. But CRUD is basically, this CRUD example that I've shown here is related to some pet database. You can think of it as like, I don't know, like a dog walker business or something like that. This web API could be used there if you want it. Facebook for pets or something, I don't know. But yeah. Okay, I noticed put doesn't have pet ID. I already answered that. Let's see. In what part of the 3 steps of client API database should we be writing the code to analyze data / give a certain output based on input? Great question. So all your processing of the data, your data processing should be done in the backend, should be done in the kind of the API part of it, right? So it's all going to be done in Python, and that's why Python is a very powerful tool for building a web API. It's because you can do a lot of data processing stuff. If you went to Shaunik's workshop yesterday, he talked about data analysis and he talked about NumPy and pandas and stuff like that. So you could do all that in Python, and when you combine it in Python with something like Fast API, which is where we're going to learn next, that's where this kind of comes about. Okay, I hope I answered everyone's questions. I'm going to go to the next slide. If you're still a little bit confused, you're going to it's going to be cleared up in just a bit when we actually start coding it. So don't worry about that. Okay, and Fast API is how we're going to code all this. It's basically the framework in which we build this kind of CRUD REST API thing that I was just talking about. Fast API is very cool. It's very high performance, which is on par with Node.js and Go. And this is thanks to Starlet and Pydantic. Those are kind of those libraries in Python that help make Fast API happen. And it's one of the fastest Python frameworks available. Being fast is really important in building a scalable web API. If your web API is not fast, you obviously will lead to slower load times and your users will have a bad experience. So being fast and being high performance is something that Fast API really boasts itself about. So it's very good. Fast to code, it increases the speed of developer features by about 200% to 300%. And that's from the Fast API website. Is that coding a Fast API REST API server will be about 300% faster. It also reduces 40% of human-induced errors, so that's really great. And there's great editor support. It's very, VS Code supports it, Atom supports it. There's great editor support everywhere. And yeah, I can go on and on about how Fast API is like the best server ever. But yeah, Fast API is really good. It's one of the best frameworks. And just to hammer it in, Fast API has native it's natively asynchronous. I can never say that word. It's natively asynchronous. Now, you might not have heard of asynchronous before. Asynchronous is basically where you're basically doing 2 things at once, right? So what Python does is Python does 2 things, right? It runs Python code in the CPU, and it also does some I/O operations. And when I say I/O operations, that's stuff like sending data through a network, reading data from a hard drive or like from the database. That's an important one, the database. And that takes a long time because you have to wait for data to send and receive. So asynchronous code makes your code run a lot faster. If you look at this analogy here, basically you can think of like you and your friend are selling hamburgers, right? And the process is that you take the order, the friend cooks the burger, and then you take the burger back to the customer. So that's a great process, right? In total, that takes 7 minutes. 7 minutes. But what if you have 5 customers? If you have 5 customers, you don't want to kind of wait for your friend cooking the burger. You want to just take all the orders and stack them up, right? So if you don't stack them up, it'll take 5 times 7, 35 minutes. But if you do stack them up, then it will only take 1 minute to kind of take all the orders. And while your friend is cooking, you can keep taking orders, and the orders will keep stacking up. But your friend is going to cook the burgers one by one. and that will take about 27 minutes. So you can see that, you know, when this scales, if you get like 100 customers, this scales very well. And your runtime improves like a lot. So yeah, so that's a note on asynchronous code. Asynchronous code is very much preferred. You could make your Python code asynchronous, but FastAPI does it by default in its framework, so you don't have to do anything extra. So yeah, FastAPI takes care of asynchronous code for you, basically. Okay, any questions on asynchronous code or what FastAPI is? Like how FastAPI relates to like a REST API, what the difference is between those? Okay, I don't see any. Okay, so I'm going to go over kind of like the web server process models really quick. So traditional web service process models look like this, right? Where you're sending a request to the web server, and the web server executes the request in kind of a thread process. So thread 1 executes the first request, thread 2 executes the second request, thread 3 executes the third request. But in Python, everything runs in a single thread, which uses far less resources, right? And a thread is basically, you know, like a single kind of worker running on your computer, a single processing unit. If you know, like the processor resting in your computer, it runs on multiple threads. So Python only uses up, or sorry, I shouldn't say Python here. It's technically FastAPI, but FastAPI runs in a single thread. And this is kind of like the async model that I was talking a little bit about before, the hamburgers and the hamburger analogy that I used before, where kind of you are free to take another order while your friend kind of cooks the burger, right? So over here, your friend is cooking the burger and you're taking another order. So yeah, so that makes a big increase in performance and scalability. So yeah. And just to kind of hammer it home, if you've kind of heard of Django or Flask before, FastAPI is the best Python framework. Its performance is rated at 100%. I forgot where this came from, but if anyone is curious, I can send you the link. But according to a Tech and Power benchmark, FastAPI beats every other framework when it comes to performance. But Flask and Django are nowhere near the top 10. Flask and Django are like all the way down there. So yeah, Flask and Django suck. So is the difference that, okay, I got 2 questions here. Is there a Node.js server involved in FastAPI? No, there is not a Node.js server. The diagram over here says Node.js, but it's kind of like the same thing because FastAPI was actually inspired by Node.js. So the developers of FastAPI wanted Node.js to basically, like they wanted Node.js, but a Python version. So they made it. So yeah, the asynchronous code thing, this web server process model, is inspired fully by Node.js. So Node.js runs on the same processor model that FastAPI does. So yeah. The reason why we use FastAPI versus Node.js is because FastAPI has a lot of like, it has like obviously Python, right? So Python has a lot of data processing models that you can use like NumPy and stuff like that. So that's why we use Python. It's the difference that the first one returns multiple times while the second one stores all the requests until you finish requesting. So it doesn't store all the requests, it manages them while you're collecting them. So it basically works on them and it keeps accepting more tasks to do, right? But the first one, it won't let you run another request until you finish all your previous requests. So basically what I mean by this is like, if I ask the web server to process another request, it's gonna take a long time because there are no more threads available. So it doesn't have like any other threads. So it'll just wait until like whatever it's doing is finished and then it'll return. But that's not the same with Fast API. Fast API can, and Node.js technically, can like process multiple requests at once. So web servers have capacity for only one thread. The more advanced ones kind of can run this asynchronous model on one thread, yeah. But they have capacity for more. They have capacity for as many threads as you give them. But more threads you give them, the more your kind of computer needs to be able to handle that, and the more expensive your server architecture gets. And in this world where server architecture is so precious, you need to find a way to kind of scale down your hardware and scale up your software, because software can be much more scalable than hardware ever can. Hardware cannot be scaled to the point that software can. So that's why we're trying to make the most use out of each thread that we can get. So that's why there's this kind of asynchronous model. It makes use of each and every single thread to the most it possibly can. Okay, so I'm sorry this might be basic, but what does a Node.js server do? So no, that's not basic. Node.js is basically kind of, it's a web server just like Fast API is, but it runs on JavaScript. So Node.js is to JavaScript like Fast API is to Python. So yeah, it's basically another kind of web server framework. We could go into it, but like Fast API is easier because a lot of people know Python, not a lot of people know JavaScript, or not as many, so yeah. Okay, so, and just to hit this home, Fast API is 300% faster than Flask or Django. So you can see a recurring theme here that I keep saying fast, and that's pretty important when you're building a web server. Okay, so real quick, I'm gonna go a little bit slower. I thought Node.js was the compiler for JS. It is a compiler, but when you're usually talking about Node.js, it's meant in the context of its web API and its HTTP requests. Node.js is used for the compiler, but like when you're talking about Node.js, yeah, you usually mean like the API version of it. So yeah, I know it's confusing. Don't focus on Node.js for now. So Mysql is an open source, is a compiler, same thing as interpreter. Basically, yeah. So an open source relational database, and relational means that data is organized in tables. But Mysql isn't really scalable, but it'll do for development. Usually developers don't really use Mysql because it's kind of limited in what it can offer. So SQL is much better. So this is kind of like what we'll be using though, because it's easier to learn. So yeah, so let's go through some common SQL terms, and then we'll use a self-contained database for the purposes of this demo. And then we'll get started coding. And when I start coding, it'll make a lot more sense. Okay, so here are some definitions. You can see my source linked over here. But basically, in this diagram here, you can see this kind of database table. So this is called a database table. And this first thing over here is an example of a row. Okay. So that's just one row in the database. Now this user is named Bob. He has age of 22, 155 pounds. You can imagine this as an Excel sheet, right? This is basically an Excel sheet where each of these kind of entries are rows. So yeah, it's just data entries, right? So a row, also called record, is a collection of attributes that represent a single entity. And the table is just a collection of these rows. And it's important that the table has consistent kind of attributes, right? So like every user here has a name, every user here has an age, and so on, right? So that's important. A query is a request for data from a database table or a combination of tables. So if you want to kind of get this data and mess with this data, you're going to have to query it, right? So that's what we're going to kind of go through now. But does anyone have any questions about the terminology? When I say row or table or query, do you guys now know a little bit about what those mean? It's just kind of data entry. storing data. Yeah, so a query is a request for data, basically. It's basically you asking SQL, hey, can you give me the username Bob or something like that. So that's what a query is. Just think about like, like a search query. When you're searching something on Google, you're querying Google. It's the exact same thing. You're just searching a database. Can SQL directly access a source like an Excel spreadsheet? So SQL's a way to store data. You can't actually like source data from an Excel spreadsheet through SQL, but you can use Python to extract that data from the spreadsheet and then pop it into SQL. So SQL will manage it better, and it will be able to like handle more of it with less kind of bytes being stored up. So yeah, it's a way of like storing the data. Yeah. Any other questions? Feel free to unmute and just interrupt me. Okay, how to write a MySQL query. So this is kind of the first query that we're going to do, but actually before I do that, I want to launch your database editor visualizer that I showed you before. Sorry, I think I messed up. DB browser. Yeah. So go ahead and launch that on your own computer. And make a new database. You can see that like click over here, it says new database. So click that. And then create a new folder on your desktop for like this demo. I called it fastapi/demo. So you can store it there. I'll delete what I have here. And you can call it like local DB or something like that. What are we supposed to click? Okay, I'll go through it again. Oh, you can't see it? Oh, that's bad. Can you see it now? What? Okay, can you see it now? Let's go. All right. Sorry about that. Okay, so I'll go through it again. So when you open up MySQL, you're going to see something like this. I'll close what I have right now. So you'll see something like this. And this is basically the app I made you download. Is a visualizer for SQL. It helps you visualize the data. Because SQL is a way of storing the data, but it's not very good at showing it to you. So we had to download another app called DB Browser to, like look at the data, and through this we can actually edit it. So it actually edits the SQL for us. So it's pretty cool. So yeah, it's just a way of looking at the data. So let's create a new database and go into the folder that you've probably created for this demo. And let's call it local down here, the file name local .db. So local.db. It doesn't matter what you call it. I just prefer to call mine local DB. Okay. And then the first thing we're going to put here is a table. So remember, a table is just a collection of records. So let's call this table users. So it's just going to be a bunch of users that are going to be in our application. Remember, we pretty much have to start from the database before we can actually build the API, because if we don't have the database, we don't have anything to kind of interact with. Right? Everything in software rests on data. So we need to actually make some data so we can actually interact with it through the API. You could make an API without the data, but it's pretty boring. It won't do anything. So we're going to make this to kind of interact with it. All right, first thing I'm going to do here is create a name. So this user is going to have a name. And the name is of type text, right? So you change it there. And what this says, NN, that means not nullable. You can see not null. So I don't want any of my users to not have a name, right? So I'll check this box. So that means that none of my users can not have a name. So yeah. And let's add a little bit more based on what I saw here. So there was age, right? Let's put age. Age is going to be a number, right? So we'll leave it like that. We'll leave it not nullable. And we'll do weight. Actually, weight can be null. If weight wants to be null, it can be null. So that means that a user doesn't have to have a weight or a height. Are we basically defining a JSON object right now? This is not a JSON object, it's a table structure. So JSON is a data format, right? But this is not in JSON right now. This is in Sql, right? So Sql has its own data format that it uses. It might have a name, but I don't think it does. It's basically just a table structure, right? We're defining the model of the table right now. So yeah. Does that make more sense, Raymond? Yeah, okay, cool. We also have ID. So ID is pretty important for like any table because it makes sure that every user has a unique attribute that it can access, right? Because if you make the unique ID name, then a lot of users might have the same name, right? Like a lot of users might have the name Bob, so you can't really make a name. So we have to create this separate ID. They'll make it not nullable. It's going to be our primary key of which we identify a user. So that's what a primary key means. Something that you can point to and say, hey, he's user 4. So it's his unique identifier. And it'll make it auto incrementable, and it'll make it unique. All right. So if you have any questions about, what I did over here, how I created this, go ahead and ask me in chat. What boxes do you check for ID again? All of them. All of them. Because it has to be not null, right? Every user has to have an ID. Every user has to have a unique ID. And we made it auto incrementable, so like if you add a new user, it'll just kind of add 1 to the ID. So the user IDs will be like 1, 2, 3, 4, 5, 6. Could you differentiate between primary key and unique? Yeah. So primary key basically is used for when you're joining a table with another table. You can join it via the primary key. So that's what a primary key is mostly used for. But primary key and unique are pretty similar. Usually, when you're building a database, your primary keys are always going to be unique. But for now, that's like a detail that you don't really need to worry about. Just make sure that whenever you're defining a primary key, know that you're using it to kind of join it with another table. So that's a concept called table joins, which we probably won't go into today. We'll just be working with one table. But when you have more than one table, it can get kind of complex. So yeah. For example, let's say I have this other table called like movies. So these are all the movies. I don't know if that's great. Let's call these pets. Pets. So for example, like the first kind of field for this can be owner, breed. And what owner can basically be is a primary key, which links to ID, right? So it's like kind of a link. So whenever you have a new user, he's going to upload his new pet, and you can kind of relate the user to his pet via his primary key. Right? So it allows you to join kind of the pets table with the users table based on this primary key that you have here. You have more than one primary key in a table. You definitely can. So you can have like the pet ID be its own ID, and you can make that a primary key. Totally can. Because you can join multiple tables together. What does a primary key do when you're joining tables again? It allows you to join based on that data field. So it allows you to say that the owner is a primary key that I want that kind of joins with the users table to generate some kind of table join. So yeah, and I know I'm not really explaining it well here. It's hard to explain. If you're curious, then definitely look this topic up called table joins. So definitely look that up. You'll learn a little bit more about that. So when you join the two tables, it only display the two primary keys. No, it doesn't display the two primary keys. It links them by the two primary keys. But you can get like all the data that you want from it. It only just displays them. It only links them by the two primary keys. That's its kind of mechanism that it uses for linking. Okay. If something is primary key should be not null as well. It should actually. If you don't make it not null, it throws an error. It won't let you create it. So yeah, if something is a primary key, it should be not null. Good question. Okay, so now that we're done with that, let's go into a little bit about how to write the MySQL query. So the first thing we're going to do is do a read from a database. Actually, let's insert some data into it because users doesn't have any users right now. Let's do it. So let's go back to kind of the users that I had over here. And I'm just going to copy some users into it. So we have some data to play around with. So let's put like, if you in this kind of browser tool, if you click this plus button over here, you can add a new user. So let's do that. The name can be Bob, age 27, weight 155, height 120. His ID will leave at 1. So yeah, this is just some data we're using to kind of play around. All right, cool. So how do you add another row? You just keep clicking this plus thing over here and it adds a lot of users. So yeah, there you go. I just added a lot of users. And if you want to delete something, you press this minus thing over here that deletes it. Yeah. All right, so we've added 3 users now. So just make sure you've added those in your own thing as well by clicking this plus button and then adding the fields. And then press write changes. If you don't write the changes, it doesn't save. So make sure you write those changes. So now we have some data that we can play around with, right? You can refresh this. And let's execute some SQL on it, and let's do some queries. So if we look back at our presentation, the way that we kind of can execute this database query, it follows this format here, right? Select these columns from this database based on this condition, and ignore this group by order by for now. I'll get to that in just a bit. But let's copy this query that I have here. Actually, let's explain it as I go. So what I'm going to do is I'm going to select the ID column, right? I want to know the ID of some user, right? From this users table that I have here, that I just created, where the age of the user is more than 20. So you can see it reads really well, right? So if I run this, it'll give me back the IDs of the user over here. If I want a different, if I want a different like data, I can do that too. It's like name from users where age is more than 20. So that's kind of how you can query the database. You can do more complex things like name, age. You can get both of them. So you put comma age. So yeah, so now you get all the users whose age is above 20. Now let's say you want to order it, order by age. So you can order it by age, and you can also do it like decrementally. It's actually, hold on. Okay, it's DESC. Yeah, there you go. So if you put DESC, that orders it, down. Oh, sorry, I think I messed this up. It's on my slides somewhere, so definitely should see that. But yeah, for now, just know that you can order it, right? Order by this age column and stuff like that. So yeah, so that's kind of how you can query the database. I want to kind of speed past this because I want to kind of actually write the code to build the API. But this is how you can order, basically query from this database. Okay. So yeah, okay. So finally, the point where everybody's been waiting for. Let's actually write some code. So load up your VS Code. All right. Oh, this is the code that I send you all emails with. Nice. Where is, okay, yeah. So load up your VS Code and open up the folder by clicking File, and then you'll see like Add Folder there. Yeah, Open Folder. So go ahead and open up the folder that you already created your local DB in. All right. And go ahead and create a new file. I'll call it application.py. I already created mine. And yours will be empty, obviously, but I'll go through what this means. Does it have to be VS Code? No, it does not. It does not have to be VS Code. I just use VS Code, but it does not. VS Code is cool because you have this like terminal here, and I really like that. So yeah, that's why I use it. Okay, so before you kind of code, you need to install these things, right? And when you have Python on your computer, you also have something called pip. Pip is your Python package manager. It's how you install everything. So to install FastAPI, you just run this query on your terminal, pip install FastAPI, and then bracket all. And then when you run that, that'll install everything. I already have mine installed, so it'll be a little bit faster. Can you type that again? It's right here, pip install FastAPI bracket all. It's first one. Okay, so mine had an error here, but if yours had an error, my terminal says pip command not found. Try pip 3.7 or pip 3.7. I think in Mac, or try pip 3. I think in Mac, you have to do like, you have to specify like the Python version. So it might be pip 3 or pip 3.7 or pip 3.7, something like that. So try one of those. So instead of like pip over here, it'll be pip 3. Yeah, pip 3 works, yeah. So yeah, I called mine pip, but yeah, it's a Mac Python thing, Mac Windows thing. Okay. And next, try pip install Sqlite 3. Not install packages, environment error. So try opening your Python, your terminal in admin mode. I think that might be it. Okay, I got FastAPI, but I got an error for it not satisfying requirement. What is admin mode? So actually Mac, I don't think you even have admin mode. But in Windows, I know what you could do is like, you could open command prompt as an admin, run as administrator, but I don't know if you have that in Mac. Okay, sudo pip install. There you go. Thank you, Kevin. Okay. Sorry, I'm not like a Mac or Linux user, so these questions really get me. All right. And then do pip install Sqlite 3. If you got an error that says not satisfying a requirement, ignore that for now. Let's see if it works for me. Okay, it doesn't work for me. Okay, I guess ignore it for now. I'm using Sqlite 3. I have it installed globally, but let's see. Let me make sure that I have this pip install command right. Just a second. Okay, sorry. It's actually this one. You have to add py in front of it. I didn't know that. So yeah, pip install PySqlite 3. These are just setup things that you'll have to do only one time. And once you have this in your Python environment, you'll never have to do it again. So just do this. So pip install PySqlite 3 and pip install FastAPI all. Works, cool. PyYAML. I have no idea what that means. Yeah, I don't know what that means, Welcome, sorry. Someone has a Mac, can help her out. All right, so now let's go ahead and get started with actually building out our application. So I'm gonna go line by line through what this actually means, and then you can kind of follow along here. So the first thing that we have here is this from FastAPI, import FastAPI. That's just an import statement, right? That's nothing special. FastAPI is the Python class that provides all the functionality for your API. So FastAPI will kind of handle, like, obviously all the server stuff. So that's why we have to import it. And then this actually creates the FastAPI instance, so that's important. So that creates the instance. And what you see here down here is the kind of the most important part of everything. So this block of code here is how you define a route, how you define a new route. Okay. So this route is placed on the root of the server, right? And the root of the server is called simply like the /, right? And what I have here is a function, right? This is how you write a Python function. I made it asynchronous. So that async thing, synchronous, which we talked about earlier. And then I'm returning this dictionary, right, that has the message hello world. And this complies with JSON standards. So it is JSON format. So any data that you return in FastAPI is JSON formatted. JSON is a standard in which you kind of pass data throughout the server or kind of a web kind of framework. So it's basically how you pass data. And to comply with JSON standard, all you need to build is a dictionary. Okay, it's just a dictionary. All right, so does anyone have any questions so far about the install or this new route that I defined, this hello world route? I'm gonna run it in just a second. Okay, I don't see anything. Yeah, it's pretty easy, right? But kind of like the most important part here is you need to make sure that you understand the format of how you define this route. Again, it can be more like, there can be more gibberish here, but I didn't want to do that. So you could do like message, because this is just a function, right? This is a Python function that executes whenever a client calls this route. So you say @app.get and then the route that you want. You could say something like hello, right? And let's go ahead and run this. So the way you run this is you go on the terminal and you type in uvicorn. This comes automatically installed. I don't have time to go into what uvicorn means, but I would love to. And then application. Application is the name of your file that you created, right? You called it application. And then colon app. App is the name of the instance, right? This app right here. Dash dash reload. Okay, so you can see it's running now. And then let's go to this URL. You can control click it, go to this URL. And now, whenever anyone tries to access your URL that you have here, it's going to say detail not found because this is not a route, right? I changed it to /hello. So whenever someone asks for /hello at your IP address at port 8000, it will say message hello world. So that's pretty cool, right? You can try to access this from your phone. The way you do that is you try to get the IP address of your computer, IP config. This works if you're on a Windows computer. If you're on a Mac, I don't know how you get your IP address. But this is my IP address here, right? So if I copy this, and if I type this out on my phone, and I do :8000 /hello, I'll get the same thing that I see here. So yeah, so I have it as blocked because I don't have it on developer mode. So right now it's like all local, but yeah, you could do it so that's exposed. Okay. And if you're curious into kind of more about how this works, I'll attach the tutorial. Okay, so I attached the website down there. So that contains documentation for everything you need to know about building this fast API server out, right? And that's kind of like what I'm going to follow here today. But I noticed that we only have 15 minutes left, so it's going to be kind of hard for me to get everything. But basically, what I want you to take away from today is the REST API model and how you can interact with SQL to kind of interact with the database through your web API. So I'll do that real quick. Okay. So let's say you wanted to find a new route, right? You'll say app.get. Get is the route type. Again, this can be post or it can be put. But since we want to make this route, we'll make it to get a new user or get a user with specified ID. So I want this route to get a user with some ID. So I'll name it kind of like user/user ID that I want. Okay. And you can see it highlights it for you, so it's pretty good for that. Okay, and I'll make this function def get user. I'll make it async like this. Okay. And then I want to define like my SQL code here to actually get this this new user that I have here, like this user ID. So let's do that really quick. So the way you do that in Python is you import Sqlite, and then you want to connect it. Let's say connection. So just follow along what I have here. So that defines a new connection. All right, and now I want to open this connection with kind of like a query that I want. So let's say cur.cursor. I'll say cur.execute. I really wish I could go through like what this means, but I'm kind of running out of time, so I can't. All right, and then I'm gonna use the description method in cur to zip this up. And let me just copy the code that I have. Okay, for now, you can just abstract this out into a function. So let's do that. So I'll call this run SQL code. I'll put this inside, like, I'll put this on chat so you can just copy paste this. Okay. All right. So I'll copy paste this into the chat. There you go. Just copy paste this into your own, like, code so you can have this and you can run this. So what I'm going to do down here is I want to get this user with the user ID, right? So I'll run the SQL code. And what I want to do is I want to say run SQL code, and I'm going to write a SQL query here. Right? Select everything, that's how you do everything, this star thing, from the users table that has the ID of user ID. I'll use Python's inbuilt string formatting. User ID. Okay. But right now, Python doesn't know what user ID is. Sure, I defined it over here, but it doesn't really know what it is. So FastAPI provides you with this thing over here where you can put the user ID as a parameter inside your function. So I just got to define my user ID as a parameter here. And I'm going to use this type function to indicate that my user ID is an int, right? That's passed in via the realm. So you got to make sure that all these variable names are the same, obviously, otherwise it won't work. But this is how you kind of work with your path. So that's kind of how it works. And then when you return, you can just return the response here, and that's all you need to do. So it's pretty easy. The only hard part here was to run SQL code, but I gave that to you. That's kind of a detail that you don't really need to worry about because you could look at SQLite 3 and get this code from the documentation. But the most important part is the way we interacted with the database, right? And the way we actually used this user ID as a way to get the user from the database. So now whenever I access this user, I can say, if I want to know who the first user is, looks like an error. Non-type object is not iterable. So that means I messed up. There you go. You got to put query in here instead of just empty quotes. That's my fault. There you go. So now when I say /user/1, I know that I have this user called Bob, whose age is 27, weight 155, height 120, with ID 1. So I get all this data over here. So that's a little bit about, like, how you can kind of take this user ID, execute a query on it, and then return the response. There's obviously more, right? You can also edit the user. So say I want to edit the user, and I want to say birthday, right? This user has a birthday. I want to know which user has a birthday, so I want to know the user ID. So I'll pass in the user ID. And then I'll write some SQL code to reflect that. So I'll call this function user has birthday, and I'll do the same thing that I did over there. Keep in mind that the most important part of this is the put that I put over here, right? When I say put, I know that this method, this route, is used for editing. And then what I can do here is I can run the SQL code. I don't really have a response, so I don't need to set this equal to anything. But I'll just say select all from users, sorry. My computer's running a little bit slow. Okay. So I want to update users, right? I want to set the age +1 equal, like, I want to basically kind of have the user kind of increment his age, right? That's what a birthday is. His age goes up by 1. So I first need to know what his age was before, right? So I need to get his age. So I'll run the SQL code that says select age from users where ID equals user ID. Okay. And then let's see what this response is, and let's see how we can actually get the age from it. Okay, so if I run this right now, where I say birthday 1, slash here. Oh, so this is actually a put method, so you can't access this through your web browser. So you need to open Postman. If you don't have Postman installed, Postman is a testing framework that you can download on your computer. It's widely used, so yeah, use Postman. And yeah, so I'm getting a message here from Pranay that it's already 9:22, so I need to wrap up. But basically, I think that's all I have for you today. What I want you to know for basically next time is look at the documentation for Fast API and try to figure this stuff out on your own. Because now that you know like kind of the basics of how Web API works, now you can go through it and basically build and write the software. Because the only thing you need to know is the actual concept. So yeah, I hope you had a good time, and I hope you learned something about how to like build a scalable infrastructure on your kind of web server and interact it with the front end. If you haven't heard already, John De Niro is having a presentation right after this, and I think the code is already sent out on Slack. So make sure to check that out. And yeah, I'm sorry I had to cut this short, but if you guys have any other questions or anything like that, make sure to hit me up on Slack or anything else. I'm pretty reachable. And yeah, that's pretty much it. I'll see you guys later. Bye, everyone.